The James Webb Space Telescope, likewise known as Webb or JWST, is a logical pioneer that has uncovered astounding insights about stars, planets, worlds, and other entrancing astronomical peculiarities, as well as setting new standards for scientific energy. Webb is hailed as the admired Hubble Space Telescope's successor. People from one side of the planet to the other are trading photographs or using raw data to make new insights. 1 year has passed since the imposing James Webb Space Telescope unveiled its first ever notable picture of the universe, stunning cosmologists across the world with its unprecedented detail. Yet its latest finding is an astonishing image of the universe, one that we have never seen before. What has been found so far by the James Webb Space Telescope? Is it raising more questions than it answers for researchers? Join us as we explore how the James Webb Space Telescope captured the most remarkable image ever found in history. The successor to the Hubble telescope has uncovered new data about star formation, universe blends, and the early universe. Just 1 month after the initial photographs were released, the images were breathtaking, revealing the universe in extraordinary detail. Since then, the number of discoveries has soared, providing researchers with a massive data goldmine. James Webb Space Telescope observations of astronomical phenomena, like tarantulas, record-breaking space smoke, stars nearly exploding, and other stunning celestial objects, have been reported. This satellite observatory's cutting-edge technology allows us to peer farther into space than ever before, uncovering previously unknown insights about the universe. A new era in cosmology has unfolded, thanks to these photographs, which are so detailed. To commemorate the first year of the James Webb Space Telescope's operation, NASA released a picture that shows a small star-forming region in the Kalamayuki cloud complex. The picture shows planes emitting from infant stars as immense dust clouds of different colors impact. Subatomic hydrogen makes up the red dust, and the presence of a circumstellar plate raises questions about a few stars, suggesting the possibility of planet development in the distant past. The image may show cosmic disorder, but according to NASA, this heavenly nursery is small and quiet compared to others. Moreover, many of the young stars in this region are about the size of our Sun, or even much smaller, making it the closest star-forming region to Earth. This image was captured by the primary camera of the observatory, the Webb Space Telescope's near-infrared camera, NIRCam, which captures vast images in 2 distinct infrared ranges simultaneously. Additionally, the Space Telescope has advanced our understanding of exoplanets, worlds that orbit stars other than our Sun. James Webb is especially adept at observing large galaxies. The satellite observatory found its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years away and has a diameter similar to Earth's. According to NASA, James Webb is the only operational telescope capable of analyzing the atmosphere of Earth-sized exoplanets. After that, the James Webb Telescope found evidence of ancient universes that, from a theoretical standpoint, shouldn't have existed. Eva Swinburne College and his Worldwide Galactic Group have discovered 6 gigantic old galaxies called stanza breakers. They could potentially change the way we think about space. These massive galaxies may have appeared between 500 to 700 million years after the Big Bang. According to the researchers' results, the telescope's infrared sensors identified them using its advanced instruments, allowing us to look back in time nearly 13.5 billion years, when stars and galaxies were much older. The immense size of the universe breakers has left scientists baffled. Galaxies in the early universe were supposed to be 10 to 100 times smaller than these. Their calculations suggest that these 6 objects might be billions of times heavier than our Sun. The amount of mass in one galaxy could be 100 billion times heavier than our Sun. Does the thought of figuring out something so massive make you uncomfortable? Even though most galaxies from this period are small and only growing slowly, some behemoths reach adulthood much faster than others. It's unclear what causes this or how it works. Joel Lader, an assistant professor of astronomy and astrophysics at Penn State University and co-author of the study, expressed his amazement at the discovery of a new class of objects formed at the Big Bang. He noted that the discovery challenges many of our previously held beliefs about the state of science. It seems that our discovery is so unusual that it presents difficulties to the scientific community, throwing into doubt the entire theory of how galaxies formed in the early universe. Many of the galaxies in this range are considered children since they are still in the process of development. However, galaxies as old as our own have been found in the early universe, which was previously thought to be impossible. Spectrometry, which separates light into its component frequencies to enable more accurate distance measurements, is still expected to verify the results. This has researchers scratching their heads, as there are only a handful of recently discovered objects for which distance and mass have been confirmed. If the data is correct, galaxy formation had to be much more efficient and rapid than previously thought. The fact that spectra confirmed our standard working system's deductions from the visuals is promising. For a long time, researchers have tried to interpret cosmic history, but a single piece of equipment might hold the key. Observations of the universe have long piqued the interest of scientists, so it's no surprise that conflicting data from telescopes could lead to a lack of clarity. Cosmologist Dr. Katie Mack has shared her insights to explain how this could be happening. She pointed out that JWST has been providing evidence of galaxies that appear to have started or developed much sooner than expected. What researchers had expected from their models doesn't stress, however, as McIntosh brought up. The telescope is catching pictures of universes more than 13 billion light-years away, and they are somewhat foggy. It seems like there hasn't even been enough time since the Big Bang for these large universes to have formed by the dates that cosmologists have been getting from the telescope. Many in the field are stressed, casting out different hypotheses, including dark matter and the Big Bang. However, we should go further into the proof to find out for sure. The telescope catches amazing perspectives on close nebulae, but fluffy little specks when it comes to faraway galaxies. The reason is that various wavelengths are impacted by different parts of the light spectrum. The Webb telescope can detect light from a source in two distinct ways. It might use a spectrograph, which works a bit like a prism, fanning out the light and examining the brightness of each color. Alternatively, it can use filters that block everything except a select range of colors. Researchers can then work out the redshift of the galaxy by comparing this data with spectra predicted for galaxies with similar attributes. What this redshift tells us is the precise moment in cosmic history that we are observing. It just so happens that many galaxies have an abundance of stars or stars that are too young for when they would have lived, according to models of galactic spectra. There are a number of possible explanations for this. The photometric readings could have been off due to issues with the telescope's calibration. Alternatively, they might have been observing a cluster of galaxies that isn't representative of the typical universe, or just a small area of the sky. Another possible explanation is that galaxy range models are designed for closer galaxies, which may not work well for more distant galaxies. On the other hand, cosmologists would face the exciting possibility of needing to completely rethink cosmic evolution if these galaxies are indeed very large, and prior estimates were incorrect. However, this isn't the only area where researchers have missed the mark, despite technological advancements. Planets that are too large to exist have researchers exceptionally astounded, and none more so than the discovery of a planet that is considered too massive for itself. This has prompted a reassessment of our understanding of planet formation and the architecture of local planetary systems, as well as the models developed by cosmologists. A planet that is multiple times as massive as Earth has been found in a planetary system around the ultracool star LHS 354, a star that is only a fraction of the size of our Sun. Until recently, researchers didn't believe such a situation was plausible, but new evidence shows that the largest planet in our solar system is actually orbiting one of the universe's smallest and coolest stars, an ultracool dwarf. We still know very little about the universe, and this finding demonstrates just how much we still have to learn. A planet of this mass orbiting a star with such low mass goes against our assumptions. These stars may have formed in enormous gas and dust clouds, and planets might emerge from the gas and dust that remain in the disk of material surrounding the infant star. However, it isn't believed that the planet-forming disk surrounding the low-mass star LHS 354 contains enough solid material to form this planet. Still, it exists, which means we may need to rethink our theories regarding planetary development. A good analogy would be to compare stars to a campfire. In order to maintain your internal temperature, you need to get closer to the fire as its temperature decreases. Planets are no different. Planets that need to be hot enough to support liquid water must be closer to stars with lower temperatures. If a planet is in a sufficiently tight orbit around an ultracool star, we can observe the planet's pull on the star's light or spectra, which causes a slight change in the star's color. On a different note, another stunning image of the ice giant Uranus, including its dusty rings that were previously difficult to photograph, has been captured by the James Webb Space Telescope. The fainter rings, which had only been observed by the Voyager 2 and W.M. Keck Observatory, are now visible. The image is a breathtaking showcase of the telescope's sensitivity. Uranus, which is 1.12 billion miles from the Sun, has 13 recognized rings, 11 of which are displayed in this stunning new picture from Webb. Unlike Saturn's even rings, Uranus' exceptional tilt makes its rings appear upright. The two outer rings were not identified until the 1986 flyby of the Voyager 2 spacecraft, as their dusty composition made them less visible. The 9 major rings were already known by then, and in 2007, photographs taken by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not visible in the Webb photos. Webb has the potential to uncover these, according to researchers. A planet's ring system provides valuable information about its formation and history. Uranus is an incredibly unique planet with its tilted orbit and lack of internal heat, so any data regarding its past would be highly valued. The remarkable atmospheric composition of this giant gas planet is something scientists hope the telescope can shed light on. No other telescope of this scale has ever been able to see infrared light, and the JWST allows us to examine Neptune and Uranus through a fresh, novel lens. Telescopes that use visible light, like Hubble, can't observe infrared frequencies, but infrared imaging can reveal previously hidden details and features. In addition, remarkable footage of a star nearing its death has been captured by the James Webb Space Telescope, with JWST sending images as recently as late 2021. Blurring star picture is among the first immaculately recorded occurrences of its kind. The colossal, dying star Wolf-Rayet 14, at 14, was caught on film by the telescope's infrared focal point as it shot out gas and dust into space. It is believed that this divine event is happening 15,000 light-years from our planet. Not sure what it implies, but it's around 58 trillion miles away. The image, which was given exclusively by NASA, shows the shiny purple remnant of the star's outer layer, which was previously a thin cloak of dust and gas, making the star flare. This shocking picture is an enhancement of the one that the Hubble Space Telescope caught a couple of years ago in 2015. Before the JWST was launched. The star on the move was recorded by the Hubble Space Telescope. It appeared to be more like a blasting ball. However, because our technology could not capture the finer details, the destruction caused by Wolf-Rayet 14 is now clearly visible. It is trusted that the consumed star, which is situated in the constellation Sagittarius, is multiple times greater than our Sun. Plus, it has expelled enough gas and dust to, in any case, cover 10 suns for the present. According to NASA, a star is at the center of this staggering new picture. For the past 15,000 years, that star's light has been traveling across the universe. It will take 15,000 light-years for it to reach the telescope's detectors. What appears to be dust around the central star is, in fact, dust because of this. When a star dies, it releases its outer layers and material into space, as seen in the image. Planets will form from this dust as it spreads out into space. This is how we arrived at this point. Experts believe that a star, in the process of shedding material, is about to explode in a phenomenon often known as a supernova. Although the breakdown of Wolf-Rayet 14 will be invisible to the human eye, 5 planets will be visible from Earth. Interestingly, a real beast in space had its appearance captured by the James Webb Space Telescope. The ghostly element was seen by the JWST as it prowled in space. In reality, it's a galaxy that produces many new stars every year, not some huge extraterrestrial. The galaxy, which has the designation Aztec C71, was first discovered nearly 10 years ago by a ground-based telescope. However, when the more refined Hubble Space Telescope analyzed it, it vanished. With the help of the James Webb Space Telescope, the long-lost galaxy has now made a triumphant return. The galaxy Aztec C71 appears as though it's shouting into the abyss in a craftsman's depiction, which gives the appearance that it has two eyes and a vast mouth. Its discovery adjusts how researchers view the early universe and raises the possibility that massive star nurseries were 3 to multiple times more common than previously thought. According to the group's calculations, the redshift of the universe being observed is approximately 6, which places it at roughly 900 million years post-Big Bang. An actual beast, this thing, its small mass is actually responsible for the birth of many stars each year. Regardless of appearances, what, in fact, excites us is that our newest telescope produces images that are so sensitive that even something so dramatic is barely recognizable. Countless galaxies might be revealing themselves to us in this way because dust absorbs most of the starlight and re-radiates it at redder, longer frequencies. Dusty worlds have proven challenging to photograph before this. Our only method of observing galaxies in the early universe had been through the optical lens of the Hubble Space Telescope, but since our eyes are limited to the visible, dust-free galaxies, our understanding of universe evolution has been skewed. However, the Hubble Space Telescope can't detect infrared properties, which the NASA James Webb Space Telescope can. Since the JWST is sensitive enough to peer into the universe's farthest corners, it can see through even the thickest dust shrouds. It will allow us to analyze the optical and infrared properties of this previously concealed group of galaxies in an effort to better understand the early universe's features. The Universe Web project plans to map up to 1 million galaxies from an area of the sky the size of 3 full moons. Despite the observatory's reputation for gazing into space at the furthest possible distance, NASA has also used its advanced instruments to make discoveries in our own backyard. Using the detailed images of Mars that the JWST captured last year, scientists can now examine more transient phenomena like dust storms, atmospheric conditions, and seasonal changes. However, Mars is a challenge for the powerful space telescope because the infrared light from Mars is blinding the instruments on board due to the extremely bright conditions. To correct for this, astronomers had to use specialized data analysis techniques and incredibly short exposures. The researchers who made these discoveries claim they will continue to analyze the spectroscopic and imaging data to search for further insights.